All right, so let's make it happen. Sorry, you're going to see this in the recording now, but that's what I have to see. So, okay, we are going to do a programming lecture actually on a Monday because our non-programming lecture has to do with like logic, and I'm going to motivate it with programming topics. So I need those topics today. I need to give them to you today. So we're going to talk about lists and loops. Okay? Loops are very important. Those are things that we have probably been dying for in Python, right? How do we make code that comes back around on itself? Gosh, that would be nice to have, especially like we were making 5 squares or we were making 10 triangles for our assignment. That got really tedious copying and pasting that code. Let's make a loop that does that kind of repetition for us. That would be so nice. Okay? So let's make that happen. That's the idea. But before I get there, I would like to actually show you a topic called errors, because things can go wrong when you're writing your Python programs. I'm sure you've seen a lot of red text just like spit at you before. Let me show you a little bit more about that. So let me go to my notes. But yeah, there are a lot of different kinds of errors in Python that you will find, but they all come from some kind of category. Okay, there are 2 main categories of errors, I would say, in Python. Here they are. They're runtime errors and logic errors. So a runtime error is an error that is unrecoverable. So your program, it hit this line that was just bad, and it does not know how to fix the problem that just occurred. That was your fault, runtime error. The program can't recover, so it needs to end itself. So the program ends right after the runtime error happens. A very good example of a runtime error is division by 0. So let me show you that code. Okay? Let's go into idle, I guess. Whee. Make a new file and let me figure out what today's lecture number is. It looks to be lecture 19, so let me remember that. Make a new folder for today. Can I not make it out of... There's not enough room, not enough empty space to right click. There we go. Alright, lecture 19, and I'll call this runtime error. And so here's a great example of a runtime error. It's like divide by 0. Divide by 0 is undefined. Once it happens in your program, it's like, what do I do? I can't give back an answer. I better stop myself. Okay? So let's have a very subtle way of getting that divide by 0. Okay, let's try that. So let's get a number from a user, like input. Input, enter a number, please. And then we'll save that in like a number called n. But remember, we need to translate from int to string, or from string to int, because input gives us back a string, right? Just the text that the user typed. We would like the number, please. And then we can like do some math with that number. Let's print, I don't know, 42 divided by that number, n, whatever the user typed. So the user could type like 2 and it would be a correct answer, right? Or they could type 0 and it would be a runtime error. We're not sure. Could be anything. Depends on the user's feelings. So 42 divided by n is, and then we print it out, right? So I'm going to print 42 divided by n is, and then a space, and then give the answer. And then I can put some other stuff down here. It's fine, like print hello, whatever I want to do. Not a problem. But let me run this. And it's like, all right, enter a number, 2. That's fine, right? 42 divided by 2 is 21. And that totally works out. 42 divided by 2 works just fine. So it continues, it completes this print statement line, and then it runs print hello. So it also prints hello. That's cool. But I could do this. Enter number 0. Look at what happens. Bless you. So, oh man, enter number 0. It tried to do this line, but it couldn't, right? It had to get all these answers first, and it wasn't able to get this last one. It wasn't able to print because it couldn't get that last answer. It's like, I cannot divide 42 by 0. You just type 0. My n is 0. I can't divide 42 by 0. So I got a 0 division error. And notice that I don't print hello. Like, the program stopped right there when the problem occurred. It couldn't even complete this line, so it definitely wasn't going to try to do anything else. So that's where the error happened. You get a lot of red. At least it's helpful to say it says like where the problem happened. But that's about as much as as good as it gets, right? That's how that works. Division by 0, that's a runtime error. Are there any questions about that? So it's unrecoverable. The program cannot fix it. All right. Yeah, so that's a common type of error that I'm sure you've seen by now when you're writing your code in Python. A runtime error, just one that stops the program. It's not working, right? It also can happen if you spell like things wrong in Python. It's like, I don't know what this variable is called. You spelled it wrong. That would be a runtime error because it can't find it. The other main class of errors that you see in Python are called logic errors, okay? These are the subtle ones. Your program doesn't stop. It just keeps running, but it gets the wrong answer. So this is called a bug. That's just a fancy word for bug. Logic error means bug. And so the standard example of a bug, right, is just you're trying to do one thing, but another thing accidentally happens. So here's my best example of a logic error. I'm sure you will find many more as you program yourself. So here's an I variable. It's set to 42. And then let's make an I plus 2 variable and set it equal to I plus 1 only. See the problem? This is going to work. I plus 2, the variable is going to hold 43, and probably your program is going to run with it and use its answer to do stuff. And it's not going to like run into any runtime errors, but you're just going to get the wrong result at the end, right? Because you should have been storing I plus 2 in the I plus 2 variable. Like you really wanted 44 to be there, not 43, right? So that's a bug. That's a logic error. The program's going to run just fine. You will get the wrong answer is all. Okay? See how subtle that could be? It's not going to alert you of the problem. You're just going to see at the very end, oh man, that's not what I wanted to compute. So there was a bug somewhere. There was a logic error. Any questions on either of these? Not too horrible, I hope. Just putting words to things that you may have already experienced as a programmer. So yeah, if we're okay with that, the next thing that I want to talk about are lists. It's a way of combining data in Python, okay? So lists are a way to hold a bunch of stuff all at once inside of a single variable, okay? So, I don't know. Also the order matters. So here's an example of a list. It's just you use these angle brackets, not angle, you use these square brackets, and then you just put a bunch of numbers one after the other, 1, 2, 3. They're comma separated, and then once you're done with your list, you put a closing square bracket. That's all. So this is the list 1, 2, 3. That's how you read it. It holds 1, then 2, then 3 in that order. Okay? So I don't know the best way to do this. Let's maybe go on the REPL for a little bit, and then we'll talk about lists in general. So here is a list. Angle bracket 1, 2, 3. Hit enter. Cool, we get the answer. It's 1. That is what it is. Yeah, it is the list 1, 2, 3 in that order. What's the type of that? 1, 2, 3. It's a list. Okay? That's what it is. That it holds those things all at once together. All those numbers all at once together. So a good thing that a list might be for is maybe storing a bunch of coordinates, let's say. Let's say we were writing a video game or something. It was a 3D video game. So we need to keep track of like where the enemies are, and maybe they were allowed to like hover and float or something. So we needed 3-dimensional coordinates for them. It's like we need to represent the fact that the enemy was like 2 away in the x direction, then 3 away in the y direction, and say like there, but it's also up in the sky a little bit, so like 5 upwards. I don't know, 4 or 5. So way up here, that's where the enemy was in space. You need to be able to represent that coordinate all at once, like 2, 3, 5. Before lists, what you would have to do is like have a separate x, y, and z variable for those 3D coordinates. Be like, all right, 2, 3, 5. And then you have to like mess with all of these. You have to keep them all around each other. You couldn't store a single coordinate all at once. But enter lists. Here's what you could do. Instead of storing 3 separate variables for this logical thing that should all be together, you could just make a list that holds 2, then 3, then 5 in that order. Does that make sense? That would make one variable that holds all of those numbers at once, and then you wouldn't be able to like accidentally mess with one and not the other. P would hold the list 2, 3, 5. And you can just pretend like the first thing is the 2, the x coordinate, the next thing is the y coordinate, and the third thing is the z coordinate. Something like that. So that's what a list is. It holds a bunch of numbers at once, and the order really matters. This list is not equal to this list, even though it has the same numbers. Does that make sense? So 1, 2, 3 is not equal to 2, 1, 3, because the order is different. Okay, the order really matters in lists. And it's just one big thing. It's a single entity to Python, even though it's made up of smaller things. All right? And you can totally set a list into a variable. So let's make a new file to talk about all that. Lists.py. I have a feeling I did not store either of these in the right folder. I'll deal with that later. All right, so lists.py, so I can make a variable that holds a list. P equals, I don't know, 2, 3, 5. And of course, you can print it out. So if I run that, prints the 2, 3, 5. But that's not really all that you could do with a list, right? You need to be able to do more things. How do you go in and get out just the 2, just the 3, just the 5? That's the next thing that I want to show you. Okay. There we go. Actually, I have one slide in between there. So yeah, you make lists by giving all the values in order, first of all. You could make them from nothingness. You could like build up the 1, 2, 3 slowly if you would like to, because lists have a plus operator that works for them. Just like strings, you know how you put 2 strings next to each other, it makes a bigger string. If you put 2 lists next to each other with a plus in between, it makes a bigger list. So this would give you back 1, 2, 3, 4. Could try that in the REPL maybe. Boop. So if I had the list 1, 2, just by itself it's 1, 2, but if I add that to another list with a plus, I get the whole thing. Beautiful. So that's how you can build things up. And so if you'd like, you could start from the empty list. The empty list is just 2 brackets right next to each other. There's nothing there. If you want to add the 1, well, I don't know. You could add just a list with a 1 in it. That gets you that one. If you want to add things one at a time, usually this would only make sense if you had it in a variable and it started empty, but I mean, you can totally do this if you really wanted to from scratch. This becomes the list 1, 2, 3, 4 because it's the empty list plus the list with just 1 plus the list with just 2 plus the list with just 3 plus the list with just 4, and it becomes logically what you would expect. Okay, so you can add 2 lists with the plus. The empty list is just some brackets. All right. One very important thing that you might want to know about a list is how many things are in it, because you can put as many things as you want. That's what len does. There's a len function that's just built into Python, just like the type function, just like the print function. We didn't have to import anything to get them. It just exists. So len, if you give a list to len, it'll tell you how many things are in it. So that one will give back 2, for example. Let's go to our list program. Let's print the len of p. What's that? That should be 3, right? There's 3 things in that list. And of course it prints 3. Does that make enough sense? Any questions about that? Just a new data structure. A way to put a bunch of stuff in one place. It's a list. All right, now I need to tell you how to get the pieces out, because like what's the point of having 2, 3, 5 in there and not being able to get out the 2, the 3, the 5? I know how big the list is, but I don't know how to get stuff out of it yet. So that process is called indexing. All right? Indexing into a list. So you can access or reset pieces of a list with things called indices. All right? So you have to index into your list and get stuff there. So let's pretend this is my list. X, the list is equal to 5, 6, 7. Then in Python, this is what it's going to store it as. It's going to look like this. Here's X, and it really has 5, 6, 7. They are really separate from each other, 5, 6, 7. And the way you get to them is with indices. And it starts at 0 because this is computer science and everything starts at 0 in computer science. So 5's index is 1 because it's the 0th thing, right? The 1th thing is the 6th. The 2th thing is the 7th, something like that. It starts at 0. So the first thing is index 0. The second thing is index 1, and so on. Don't forget about that. That will bite you one day. So that's how the indices work. Okay, so if you want the second thing, you need to access the 1th index kind of idea. And the way you do that in Python is you use the name of the list, maybe you have it in a variable, or you just give the list itself, and then you use brackets, kind of like you're making a list, but you just put it next to the name or the list itself. And then you give what index you would like. So, for example, you could ask for X at index 0, that's the syntax, and that will give you back the 5. That's what's stored in the list at index 0. Does that make sense? X at index 2 would give you back the 7. That's the thing stored there. Okay, so let me just show you that real quick. So let's go to our lists program, print P of 0. That should print the 2, right? Because that's the 0th thing at the 0th index. That'll print my 2. That's how you can get it out. And then you can print other indices, of course. You can print what is P of 2. It's 0, 1, 2, so that should print just 5, that line. Okay, that's how I can get the 5 out now. Does that make enough sense? Any questions about that? Yeah. Another cool thing about Python that doesn't exist in every language, if you learned another language, this doesn't exist in C++, for example, you can go backwards. You can have negative indices. So if you just wanted the last thing, you don't have to compute the last index. You can just say, hey, give me X at -1, because this is the -1 index. It's always the last thing. -2 is always the second to last thing. -3 is always the third from last thing. So there's secretly 2 valid indices for every place in a list, starting from the beginning or starting from the end. Yes? What would be the benefit of going backwards? Well, it just depends on what you're trying to do. Let's say, I don't know, the user gave you what's a good example? Maybe you're dealing with some sort of online store and you're dealing with prices. So you're getting a list of prices. Maybe it's sorted from smallest to biggest, or maybe biggest to smallest, and the user just wanted to look at the cheap thing, so they clicked the sort the other way button. You could just go backwards through that sorted list now, and you get the opposite order. Does that make sense? That would be one example, maybe. But yeah, it depends on what you're trying to do. But there are cases to want to go in reverse through something. That's for sure. Yeah. Any other questions about that? So that means that I could say X of -1, and that would also give me 7 here. I could say X of -2, that would give me the 6. Yeah. So what's this example? We haven't printed the 3 yet. Let's use negative indices for that. It's the second to last thing. So index -2. This is -1. This will be -2. That'll give me the 3. There we go. 2, 5, and then 3 this time. So yeah, that is how you can get stuff. You can use that same syntax to set stuff. You can just say, hey, x of 0 becomes something else. P of 0 becomes something else. You can do it like this. You can set P of 0 to 7, for example. You can use the same syntax to set, to change an index, the value at an index. So this is changing P0 to be 7. And now that changes the 0th index. And now instead of 235, it's 735 after this line. Print P. Now it's 735. So you can change it just as easily. You good with that? All right. If we're doing okay, I have a question for you now. So pretend you have this list. It's called capital L. It has all these numbers in it. How would you get this 5 out of this list? There are two options, right? Which indices would be that one? How would you print the 5 in two separate ways using two separate indices? Do you understand the question? Write down two different ways to get that 5 out using those indices. See if you can figure that out. You don't have to physically write it down, just try it yourself. I'll give you a couple minutes to help each other with that, and then we'll come back and look at the answer. How would you print the 5 from that list? You got two options, right? Take about one more minute while I try to find the source of some high-pitched noise. All right. So, yeah, which were they? What are the two indices that could give you the 5? What did we come up with? Nice. Let's confirm that. So remember, they start at 0. So that's the 8 would be the 0, the 6 would be the 1, 7 would be 2, the 5 would be the 3. Yeah. 4, 5, 6. And alternatively, you could start from the back. -1, -2, -3, -4, -5, -6, -7. So yeah, if you wanted the 5, you could either print L of 3, or you could print L of -4. Okay, any questions about that? You have options. So yeah, just remember that indices start at 0. That's probably the key thing to remember. Otherwise, you'll be off by 1. You'll be very confused. All right, so yeah, the next thing that I want to show you is loops. let's talk about loops now. Let's actually make those in Python, because we need a way to like start some stuff, do some stuff, and come back to it. That would be so nice to have. So let's figure out how to do that. Because in Python, our loop block in Scratch, our loop block looks something like this. You have like some stuff, forever loop, a condition, then you put stuff in between here. That's going to get translated into like some stuff, like your condition, and then a colon, then you enter, you tab over, and then you give what stuff you want to have in here. That's essentially how it's going to look in Python land. You're going to need text. You're going to need to indent. Like, what stuff do you want to do? How do you want to do the looping? Okay? So that's going to be the goal. But yeah, it's just a new piece. It's new syntax, but it's a concept you already know. So, just like in Scratch, a loop repeats something, and you get to control that repetition. All right? This is the standard way of doing it. In Python, the standard loop is called the while loop. So it's just you say the word while and then you give a condition. So a while loop, it executes its body, so it runs the code inside of it, as long as a condition is true. So this is essentially how a while loop works. It always starts at checking a condition. That's how the while loop begins. Condition. It checks that, sees if it's true or false. If it's true, capital true in Python, right? It runs the body, which is all the stuff you wanted to have happen whenever the loop repeats. It's all the stuff you wanted to repeat. It can be as much stuff as you want. You didn't indent it all. And then it goes back and checks the condition again. As long as the condition remains true, it's going to repeat that body. And that's what a while loop is all about. But then the second that it becomes false, it's done. That's when it stops the loop. Okay? So the second it becomes false, then it starts running the rest of your code outside of the loop. The loop is over at that point. Okay? So that's how it's going to work. It's a while loop, it's called, and then it starts at checking a condition, and then if the condition is true, it runs its body. As long as the condition is true, it keeps running its body, and eventually it'll become false. Stop the loop. Okay? So yeah, let me show you an example of this. Gosh, I don't know if I want to do that one first or that other one first. Let's see here. I think I want to do an infinite loop first, actually. That would make the most sense. So here is the idea. Here's a while loop in Python. It looks a lot like an if statement. It's just that the body gets re-executed, but the syntax is very similar to an if statement. You say while instead of if. While, and then you give your condition here, and then a colon. And then you tab over, of course, or give some spaces. There has to be indentation, because that's how it differentiates where the body is for where it ends. And then this is the body. This is the body of the while loop. Okay? That's how it looks. And so it's going to keep running this body as long as the condition is true. And eventually, if it becomes false, it'll stop the loop and do the rest of the code that's unindented down here, just like for if-else. Okay? So while the condition is true, it executes the body, and it repeats it. Repeats that, checking the condition, running the body, as long as the condition is true. The second it's done with the body, it immediately goes back and checks the condition once more, because maybe it needs to repeat. Usually, right? It would need to repeat. So probably the first question is, how can we make a forever loop in Python? How can we make a program that just does the same thing and never ends? You have to like click the X or something. Well, you just need to give a condition that's never false. True is not false. True is never false, right? So an infinite loop, a forever loop, is you just say while true. Because this will never be false, and so it'll always run the body forever and ever. Always gets executed. And so that's pretty fun. Let me show you that. I'll show you an example with printing stuff. So I don't know. What do I want to call this? Let's say forever loop.py. And so to make a loop that runs forever, you say while, and then you give a condition that's never going to be false. So just say while true. True is never false. Indent over, and you can just do whatever you like. Print stuff. Print hello world. And I could do this. I can just I can unindent and get down here, but this code will never get run. Print, we will never get here. Da da da. Because we're just always going to be coming back to this body. We're going to repeat this line until the end of time. We will never stop the loop, so we'll never get here. Does that make sense? We're just always going to be repeating the body of the loop, and the body is this one indented line. So this is it's going to print hello world forever. Run. Oh, oops. I forgot to end the string. Excuse me. Syntax error. Whee! There it goes. And so if you ever have a program and you didn't expect it to have an infinite loop, you can of course just stop Python and click the X, but you can also type Control-C. Control-C just will stop your program, get you back to the REPL. So if you have a runaway program, it's got an infinite loop in it, just type Control-C and that will stop it. Because a lot of the time you didn't want to really write the infinite loop, it was accidental. But that's how you write one if you want it. Any questions about that? So while true will always work. And of course, we never got to this line because we were always repeating the body for the end of, until the end of time. So we'd never get there. So yeah, let's talk about some loops that do other stuff now. Let's have loops that go through something. Let's have loops that iterate. All right. Let's print the numbers from 1 to 10 in order. Let's do that. Okay. So the only way we could do that before was all right, print 1, then print 2, and then print 3, all the way to print 10. That is cheating. We can no longer do that. It's so much easier to do it this way. So let's start an I variable at 1. That's the standard variable that people like to use. It's like loops iterate. I stands for iteration, kind of. It's not really the truth, but that's partially the truth, I would say. So let's just use an I variable, and that will keep track of what we're done, or when we're done, and what we want to print out. So here's how we could do that. So we'll get our I variable, we'll start it at 1, and then we will repeatedly do the following. Repeatedly, with a loop of course, we will print the current value of our I. So like the first time we'll print the 1 because I is set to 1. But then we will also increment I. So we printed the 1 because I was 1. If we increment I and come back around and do this again, next time we see this line, we'll print the 2 because I is now 2. Yeah, you see how that's going to print up to 10? So I is 1, 2, 3, and you keep doing this until I gets to 10. You print the 10, increment I gets to be 11, but we don't want to print the 11. So we want to keep printing as long as I is less than or equal to 10. Does that make sense? Or if I were to use a synonym, while I is less than or equal to 10. Okay? That's the idea. So let me show you that. So we're going to start our I variable. Let's make a new program. Call it loops.py. So I'm going to start an I variable at, let's see, can I hide this zoom window? Will you go away? Yeah, hide meeting controls. But they keep coming back. Can I? How do I do it? Huh. I want that to go even farther. Oh, does it? Like this? You'll have to show me sometime, but I'll just put it down here. That'll be fine for now. I equals 1. Please show me after class, because I would love to know how to get rid of that. I is 1. It starts at 1. Oh, that would be exciting. So yeah, I'll try that. I'll give that one more try. If I can't do it, show me after class. I is 1 while I is less than or equal to 10. I want it to repeatedly, right, print I, increment I. And don't forget your colon. So I want to print I and then increment I. I equals 1 more than it was before. Increment I. Okay? That's the idea. So does that make sense why this will print from 1 to 10? Run module. It goes from 1 to 10. So I starts at 1. It will repeatedly, as long as I is less than or equal to 10, print I, and then make it 2. Print 2, because 2 is less than or equal to 10. Print the 2, make it 3. Print the 3, make it 4. Print the 4, make it 5. As long as I is less than or equal to 10. So the last time this will work is when I is 10. It'll print the 10, make I 11, but now 11 is not less than or equal to 10. Right? That'll stop the loop. Then it's finally false. Okay, does that make sense? Any questions about that? That's the idea. All right, I'm trying this one more time. Up. Something's supposed to appear though when I do this, you say? I'm holding it. Okay. This is for the projector, sadly. Now this is disconnect from the projector. Now this is for Zoom. It's two separate things, unfortunately. I know I got it like this on my home computer, like this goes away. And I could just drag this green and red part, but no. Come back everything else. Oh well. We'll figure it out one day. But I hope it's helpful to the one person that's watching right now. So yeah, that is loop from 1 to 10. Let's try and do it in reverse, right? How would we do this in reverse? How about, well, instead of starting I at 1, if we want to print 10 then 9, like I better start at 10, right? And make it go downwards. Come on, controls. I'd like you to at least hide yourself. That's so unfortunate. I'll get good at this one day. Okay, just go down here then. So, here is the first option, and then let's print some spaces in between. And then let's do the other way. Let's count down. Let's start I at 10, and then let's go downwards. So I want to print 10, then 9, then 8, then 7. So it's going to be while some condition. And I want to print my 10, right? I is 10. And then the next time I want to come back in this body, I want to print 9. So I better get smaller. I equals I minus 1. And I want to keep printing, right? I is going to be 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. I want it to stop at 1. So keep printing while I is greater than or equal to 1 this time. That's one way to do it. So that'll print from 10 to 1. Any questions about that? Does that make sense? Give me this meeting control so I can make it go away. Instead, if I press Alt, it would hide it, but it's not hiding it. That's no fun. Share sound. Hide flare. There we go. Oh, yeah. I don't know how to get them again, but that's okay. I don't need to stop sharing. Now I know. Cool. All right. So, all right, let's sum the numbers from 1 to 10 now. We know how to do that, right? Again, we just need to visit all the numbers, like let I have a chance at being 1, then 2, all the way to 10. And I will keep track of their sum, like I starts at 1. I'll keep track of their sum in a sum variable. I need one more variable to keep track of the sum, and that could start at 0, right? And I'll repeatedly add the value of I into sum. So bring in the 1, make it 1. Bring it, make I 2 now, because that's the next number I want to add in. Then bring the 2 in, right? You remember this algorithm? Now it's 3. Then make I 3. Bring the 3 in. Now it's 6. And eventually, we're going to get to the final answer. It's going to get to be 10. We're going to add the 10 in and make it like 55, I think. And then it'll become 11, and that's when we want to stop. So that's what we can do. That's how we can do it. That's how you can sum some stuff. Again, you want to visit every variable, every value from 1 to 10, you can loop through them. While I is less than or equal to 10, add it to our sum variable. Let's start our sum variable at 0, let's say. While I is less than or equal to 10, let's add the current value of I into sum. So that's instead of printing it, right? We're visiting all 1 through 10, but now we're going to save them away in the sum variable. We're going to add them all together. So sum equals whatever it is plus the current value of I. Add in the 1, add in the 2, add in the 3. And then we'll increment I again. I equals I plus 1, increment I. Okay? So that should add in the answer, right? So once this loop stops, we visited all the numbers from 1 to 10, and we should be holding them in sum. So now sum holds the correct sum of 1 plus 2 plus 3 all the way to 10. Okay? That should do it. And then we can print it out. Print the sum is, then a colon. If I use a comma, it'll immediately enter space for me. And I can print the value of sum. And I believe the answer is 55. Okay, the sum of all those numbers is 55, so I visited all of them in this loop. I got a chance at being 1, 2, 3, all the way to 10, and I ran this line with each of those values for I, and so sum got placed into it, got added in 1, then 2, then 3, and it's building up the answer. Okay, and so the final answer, once it's done, it's seen all the numbers, it's added all the numbers into itself, would be 55. Any questions about that? So just to spell out the reverse process, just to make it a little bit more intuitive sense, like why did we flip things? Why was it I greater than or equal to 1 when going from little to big was I less than or equal to the final answer? Let's think about that. So if we wanted to print in reverse, and we did, we start at 10, 9, all the way to 1, 10, 9, 8, 6, 7, 5, 4, 3, 2, 1. So repeatedly, right? Repeatedly, we want to print our I. If the first thing we want to see is the 10, that means I better start at 10. And then the next thing that we want to see is 9, we better decrement, right? Decrement I. That's what we needed to do. Make it 9, because then I'll print 9 next. Make it 8, then I'll print 8 next. Make it 7, then I'll print 7 next. All the way to 1, we'll print our 1, and then it'll become 0, and that's when we want to stop, right? We don't want to print the 0, we want to be done then. So we can't do the following. We can't say, I want to print while I is less than or equal to 10, right? Because 0 is still less than or equal to 10, right? Negative 1 is less than or equal to 10. It would print forever. If I did it this way, if I said less than or equal to 1, or 10 or something, if I did this one, it would never even start, because 10 is not less than or equal to 1. But the flip side just wouldn't work out. Okay, and I hope that makes sense. So you want to keep printing. It's always something that you want to be true for all of these numbers. What's true for all these numbers and is not true for the next number that's going to come after that 0. You want to keep printing while I is not less than or equal to 1, because if I starts at 10, it'll just never work. That's not true for 10. It needs to be true for 10 and 9 all the way to 1, but not 0. So while I is greater than or equal to 1 will be the answer. It's true for 10, 10 is greater than or equal to 1, 9 is greater than or equal to 1, 1 is greater than or equal to 1, but 0 is not greater than or equal to 1, so that will stop the loop. That's how you determine that condition of your loop. Does that make enough sense? Any questions about that? Because I'd like to try and bring this all together now. So we talked about lists. Let's talk about loops plus lists together now. Let's do that. So you can do this. You can go through a list. You can iterate through a list, visit every element with a while loop. Let me show you how. So let's say we have this list and we like to print out all the pieces of it. Let's say we just want to print out each piece of that list. Print the 1, the 2, the 3, the 4, and the 5. Okay? We just need to go through and print every value at every index, right? So we can, instead of trying to figure out, okay, let's do x of 0, x of 1, x of 2, when do I stop? This can be a problem of indices. Figure out the first index to print, the last index to print, okay? So the first index is always 0 for no matter the list, right? The first index is always going to be the 0, assuming the list has stuff in it. This is index 1, index 2, index 3, index 4. The question is, how can I figure out that 4 is the last index of this list? Because I don't want to go past it, right? Say I had this list, x equals 1, 2, 3, 4, 5. So x of 0 is the 1, x of 4 is that 5, but x of 5 doesn't exist. There is nothing after it, right? There's nothing over here. So that would be an error. I don't want to go that far. List index out of range. How do I know that the last index is 4? How can I find that? Well, here's a cute answer that's always going to be true. It's always the last index is your length minus 1. Because it started at 0, that's why you do the minus 1. So there's length will give you back 5, right? There's 5 elements in this list. 1, 2, 3, 4, 5. There's 5 things there. And so the length is 5. Minus 1 is 4, and that's the last index you ever want to look at. Does that make sense? So you start at 0, go up to this, whatever this number is, and that will give you all the indices you want to try. So let's print our list with a while loop. Here's how you can do it. You can be like I equals 0, that's the first index, while I is less than or equal to len of x minus 1. So that's the last index I want to try. Then I can do stuff with x of I. That's how I can access that element. It's just, all right, I is 0 the first time, that's the 0th element. The next time I come inside this loop, I would like to visit the next index. So I will set I equals I plus 1, so that the next time I come around, I is set to 1, and if I try to access x of I, I'll get index 1, which will give me the value 2. Does that make enough sense? So you can use a variable as your index. And depending on what it is, you will go to a different place in your list. And that's pretty nice. And you know that the last valid index is this one. So just start at 0, go up to this one at a time. You will have gone through every index. Visit them all with this notation, with the syntax, and you've seen everybody. You can print them all out if you'd like. So let's go back here and let me make a list. Boop. And so let's make a large list. L equals, I don't know, 5, 6, 7, 8, 9. They don't have to be in order. 1, 13, doesn't matter. And now let's visit everybody. Let's put this up here now. So I would like to visit every index of this list L. What are all the indices? So the first index is 0. The last index I want to look at is index len of L plus, or len of L minus 1. I don't have to think. Len will do all the thinking for me. And now I can use that I variable. I will tell me the next index I want to look at. All right, so len of L minus 1 is the last index of every list. No matter what list it is, len of L minus 1 is its last index. And then 0 is the first index of every list. Can't spell that today. All right, so now once I'm in the body, I has a value. It's a valid index of my list L. So I can do stuff with L of I. For example, print it. So print whatever's at L at index I. Could be 0, could be 1, could be 2. So this will print L of 0 the first time. And then if I wanted to print L of 1 the next time, I need to increment my I. I equals I plus 1. Because then when we come back to this list, hey, is 1 less than or equal to this length? Well, yeah, it is. The length is pretty big. So print L of 1. Make I 2. Print L of 2. That's what's going to happen. And it'll stop if we try to get past this last valid index. It won't go any further. All right? And so here it is, printing out that list, all of its elements in order, 5, 6, 7, 8, 9, 1, and 13. Are there any questions about that? Does that make enough sense? So you can use your variable to talk about which index you want to look at. And you can go and get the value there with your lookup kind of syntax, your indexing syntax. See if you can figure out how to do this and go through the list in reverse. How would you print out the 13 first, the 1? There's two ways to do it, right? You could start I at -1, use your negative indices, or you could start I at len L minus 1 and go down to 0. Also works. You got options. But yeah, are there any questions about using lists and loops together? I have one last example for us, and it should bring it all together. We can finally improve that example that we did last time. Okay? Here's my fun last example for us today. Let's make a program, using the turtle module, of course, that draws not 5 squares, but 50 squares of random sizes at random locations, but let's also have them be of random colors, too. Ooh, this will be fun. So let me copy in my code from last time. Random squares. Am I able to access that? I don't know. But I'm going to call this random squares.py. And let's see if I have my recent files available to me. Ooh, yeah. So here it is. Let me copy and paste all this stuff from last time. And then we'll make it better. So we didn't have loops last time. We had to like copy and paste all this code. That's no fun. We can use a while loop now. So turtle shape is turtle. Let's not have the user enter a color. We'll deal with that later. But do you remember how just this amount of code here was picking a random location, a random size for our square? So starting X, starting Y was a random location using the random module. Random.randint gives you a random number between these two numbers. So I picked random places. I went to that random spot, and I drew a square of a random size because I picked the random side length. Okay? So I did that once, twice, 5 times. Let's delete all those copies. That's no fun. Let's do that with a loop. Let's do it 50 times, 50 squares. So how can I do something 50 times? Let's make a loop that goes between 1 and 50. So I starts at 1 while I is less than or equal to 50. Do all this stuff. Make it the body. Why not? And then I equals I plus 1. Well, I'm not using I for anything other than counting how many times I'm doing this body, right? I will go between 1 and 50. I will be drawing 50 squares at random locations. Are there any questions about that? Does that make sense? This will draw 50 random squares at random locations. Are we all clear on that? Because this is the code to draw 1 random square. I made it the body of the loop. And I started counting at 1. It goes to 50. So that'll execute 50 times the body. That's pretty fun. So this is going to take forever. So let's change the turtle speed. Turtle.speed fastest. That's something you can do. Make him run quickly. And now the default is black, so that's no fun. Maybe it is for you, I don't know. But it looks pretty cool. It's drawing some weird abstract art. But what I'd like to do next is make every random square of random size and location also have a random color. Let me show you how to do that. So we can turn this into a problem of picking a random index of a list. So here's how you can pick a random color. You can make a list of colors, and you could index into a random place in that list. Let me show you that. That'll be cool. So let's pick a random fill color. And that'll make it really cool. So colors, here are all the colors that I like to use. I'll make a list of them. Red, orange, these could all be given to turtle.fillColor, right? Orange, yellow, green, blue, purple. So here's my list of colors, and I would like to set turtle.fillColor to one of those colors, right? A random one of these. Does that make sense? Pick the red this time, the yellow next time, etc. If only I knew how to get into one of these places randomly. Well, I can do that with an index. Pick a random index. Right? So what are the valid indices into the colors list? It's 0, 1, 2, 3, 4, and 5. 0 through 5, right? We know how to do that. So random index is, well, random.randint between 0 and 5, or 0 and len colors minus 1. You don't even have to think. You could make a bigger list and this would still work because it would just count for you. Len would count for you. So this would give me back a random number that is a valid index into this list. I don't know which one. It's random. I can set the fill color to the colors list at that random index. Maybe the random index was 0. It would have picked red. Maybe the random index was 5. It would have picked purple. Does this make sense? This is how it's picking a random color from this list and setting it to be the turtle's fill color. Any questions about that? That's a fun little idea. And it's going to make for a very cool program. Are we ready to see it run? All right. Whee! So that's pretty cool. Look at that. Random every time. Seems like it's randomly not picking green very much. There it goes. But that's 50 squares, random sizes and locations, but also random colors. Every time it picks a random fill color from this list of colors by picking a random index and setting the turtle's fill color to be the colors, the index into the colors list at that random index. That will give you a string back. That's exactly what fill color was expecting. Maybe red, maybe green, maybe purple, whatever it was. And then draw the rest of your random square, begin and end fill, and just do this 50 times with a loop. And so it's random, so it'll be different every time you run it. And you can create beautiful abstract art. I encourage you to try this with your programming assignment. Use a loop if you'd like. You're forced to use the color that the user typed, though, for that assignment. But yeah, please play around with this. I think it's a fun little idea. Are there any questions about it? Yeah, study this code, steal it, make cool phone backgrounds with it or something. All right, so I think that's everything for the lecture that I wanted to show you. I think I usually wait to release your programming assignment on the next time, so I think I'll wait for that too. November 10th is when? Is that correct to do? Yeah, that'll be a Thursday. So I will wait to release your programming assignment 7 next time. Okay, so that's everything that I wanted to do today. The rest of the time is yours to work.